so now we're going to do something really exciting. We're going to learn how to conduct t-tests with our data file. And we're using the same data file as before. This file with this name is available to you through Google Drive, or you can get to it through the assignments link in Canvas. But it's just the same file that you used when you finished assignment number 1. So for each of the questions that we're going to answer, we're going to learn how to write a proper conclusion statement, how to run the analysis, how to look at the output, how to interpret the output, and then we're going to be able to write our concluding sentence. And hopefully all of you have taken the opportunity to use the PowerPoint presentation to practice identifying which type of t-test you need for each of these questions. If you haven't done that, I encourage you to do that before you keep going here, because I'm about to tell you which type of test we need. So to answer this question of whether or not this subset of the data with a smaller sample size of 5,000 is representative of the larger data set, we're really asking the question, we're considering that larger data set to be the population. And so we're wondering if the average age for this sample is the same as, which would mean there was no effect or no difference, or different than the mean for the population, which we're given as 49.30. So because we're comparing a single sample to a population, the answer here is that it's a single sample t-test. Okay, and make sure you write that in on your homework, because that tells me that you know what type of test you're doing. Okay, so what we're going to do next then is that we're going to go over to our data file, and all of the t-tests are located under this analyze choice. Makes sense, right? We're doing an analysis, and we're going to compare means, and you can see all the t-tests listed out there. So in this case, we're doing a one sample t-test, or we've called it a single sample t-test. It means the same thing. We'll click on that, and sorry about that, I got everything in there already. So let me just show you what you're going to do. You're going to find age, because that's the variable we're interested in. You're going to shoot it over here as a test variable. And then importantly, you're going to set this test value to be the value that we want to compare to, which is the 49.3, which is what we were told in the question. We're comparing it to 49.3. Okay? So after you've put that information in there, I want you to hit paste. That will put you into the syntax window where you can see the commands that are necessary to run this analysis. You can highlight those and hit the green arrow, and that's going to run that analysis. And what you get on a single sample t-test is you get two tables of data. The first table here shows you the descriptive information. So you know that you have 5,000 subjects. You know that their average age is 49.38. This is the standard deviation, and this is the standard error of the mean. The data down here is actually the results from the t-test itself. And importantly, you can see that up here at the top, it shows that the test value is 49.3. So you always want to kind of double check that to make sure that you remember to enter that important information there. And the results here, these first three squares, really tell you the results that you're going to write into your concluding sentence. And so one of the things I want to teach you about that's a little bit tricky when we start looking at SPSS output is that the significance result is written differently than what you're used to. So what we've done in the past, let me just switch over to this image. What we've done in the past is, if we have a distribution of all the possible t-values, what you've done in the past is you've said, okay, I know the degrees of freedom, which is 4999, all right, because I have 5,000 subjects. And so that tells me then that if I go to the t-table, which I have pulled up somewhere, and I look down here at infinity because it doesn't go that high, and I come up to the proportion in two tails combined, 0.05, I see that my critical value is 1.96. So I've drawn that in here. So we've got critical values of plus 1.96 and minus 1.96. And what we've done when we've done by hand is that we've solved for t, and then we've compared t to t crit. Okay, and that's great, and we could still, in fact, do that for this assignment. Okay. But what's different when you get the output is that the computer can tell you exactly what the probability is of this t-value. It can tell you exactly where this 0.307 is on the t distribution. And so what it's telling us is that a likelihood of getting a t this small is huge, right? And that's much bigger than our alpha, which is 0.05. So let me go back over here for a second, okay? So the computer is saying to us, okay, the t-value is 0.3, about 0.3. Well, 0.3 would be about right here, all right? It's 0.307, I think, right? And so the probability of getting a t this small, and it also considers that it could have been negative, All right, the probability of getting a t this small is huge because it's telling us what the area of the curve is in this part of the graph. And so it's telling us that the probability of getting a t that small in this case is actually 0.759. Okay, I hope that makes sense to you. So when you're looking at SPS output, you're going to look at the significance column, and it's almost like you want to think of alpha as a p-crit, if you will, a probability crit. So the critical probability that we've said is 0.05, that's what we set alpha at. And we look at this and we go, my goodness, this is way bigger than that. So it's not less than 0.05. The probability of getting a t this big isn't small. The probability of getting a t this size is huge, which means it's chance. Okay? So what that's telling us then is that this mean of 49.38 is not significantly different from the mean of 49.30. And so once you figure that out, then you're going to write that in right here with the conclusion sentence. The average age of the sample is not significantly different from the average age of the population, which we know was mu equals 49.30. And I always do this, and forgive me, I write that out and then I remember, oh, I should go back here and put this in. So the average age of the sample, the mean for the sample was 49.38, and the standard deviation, we also know, I'll go get that in a minute and fill that in. And then we put t with 4,999 degrees of freedom equals 0.0337, because that's what we found. And now we write p greater than 0.05, because the probability of getting this was huge. And this was conducted as a two-tailed test. Okay, so we'll just go back, take a quick peek. What was I looking for? Yeah, standard deviation 18.35. So we'll put that, we'll put that into our conclusion sentence. Okay, so we failed to reject. Maybe I should have said that out loud as well. We failed to reject because our p-value that we solved for was not less than 0.05. It was, in fact, greater than 0.05, which means there's no significant difference. All right, let's go on to the next one then. What test would you use to determine if there's a difference in BMI between men and women? Okay, so you're comparing men and women, two independent samples. So this is an independent samples t-test. Okay. And one of the things that's a little bit tricky about SPSS is that the first thing you have to do is you have to identify the levels of the variable you want to compare, because SPSS asks you to put that information into the command. Okay. So what I usually like to do is to go over to variable view, to look for the independent variable that I'm going to be using, which is sex, which is up here near the top. And I'm going to say, what labels did I use? Did I use 0 and 1, 1 and 2? What did I use? Well, it turns out I used 1 and 2. Okay, so once I know that, now I'm ready and I can analyze from this window or go back to data